Honeywell direct couple actuators, or DCAs, are used to operate valves or dampers in HVAC applications. An air handling unit is a central air distribution unit providing conditioned air to a building. Air handler units generally use fail-safe or spring-return DCAs to control the dampers. Fail-safe DCAs have a built-in spring or other means that drive the actuator back to its normal position. This is the position the actuator goes to when power is removed. It may be either normally open or normally closed. Air handlers need to bring fresh air into the building, and the actuators for these outdoor air dampers are usually normally closed. Some air handlers use hot or chilled water through coils to condition the water. These often use valves that are controlled by direct coupled actuators and may be normally open or normally closed. Another application for DCAs is with economizer systems. Economizers use outdoor air to cool buildings when the outdoor air is cool and dry enough to use in place of or in addition to mechanical cooling. The outdoor air is mixed with return air to deliver air at a certain temperature to the space. They often use a single DCA to control both the return air and outdoor air dampers. Other units use two actuators. Many buildings use an economizer panel like the Honeywell Jade Economizer. Larger buildings integrate this function into the building automation system. For more information on economizer systems like the Jade Economizer, check out Air Economizer Fundamentals training at the video library on buildingcontrols.honeywell.com. VAV, or variable air volume units, also use DCAs. VAVs control the airflow to a specific zone of a building. They are driven to this position one of three ways. They may be floating, where the actuator is driven open or closed and then stopped at a certain position, or they may be proportional, where the control signal of a certain voltage or amperage is used to instruct the actuator to drive to a certain position. And lastly, actuators may communicate with the controller using computerized signals over a communicating bus. Since the actuator in VAV boxes moves the damper only slightly in response to the temperature changes, it usually does not fully open or close the damper. Because of this, VAV boxes generally specify design life of the actuator by the number of actuator repositions, not full open or close cycles. All Honeywell DCAs are rated to provide at least 1.5 million reposition strokes. Some VAV units have a reheat coil to warm the air. The reheat coil uses a control valve that may have a direct coupled actuator. This is often non-spring return and controlled with either a floating or modulating proportional control signal. Another common DCA application are fan coil units. They are used to condition a single zone, such as a classroom, conference room, or hotel room. Unit ventilators are similar, but they also bring in outdoor air. They consist of dampers, a filter, a fan, heating and cooling coils, and controls. They heat or cool outdoor air, return air, or a mixture to condition the space. The heating may be done with hot water and a coil, steam, or electrical resistance elements. The cooling may be chilled water and a coil, or mechanical refrigeration. Because of size constraints due to their size, these units require small actuators. The valves may need actuators that are fail-safe, where they return either to the open or closed position, or non-fail-safe, where they hold in the last position when power is removed. Unit ventilators need a spring return actuator for the outdoor air damper. They may have a return air outdoor air diverting damper that is controlled by either style of actuator. Honeywell direct coupled actuators can be used in a variety of HVAC applications. Different applications require different torque levels, control type, and require either spring return or non-spring return capabilities. In North America, the part numbers start with an M, but similar actuators are sold into other areas that may begin with a C, N, or S. Let's take a look at the Honeywell DCA portfolio. Honeywell offers a full line of direct coupled actuators available in models with and without spring return. The first letter M indicates it's a motor. The S and N indicate whether it's spring return or non-spring return. This may be referred to as fail-safe and non-fail-safe. The next two numbers marked with X's here indicate the type of control signal the actuator accepts. This may be on-off two-position control, floating, proportional, or communicating. The next two digits specify the rated torque of the actuator in Newton meters. Here's a more detailed nomenclature tree with an example. As you can see, part numbers for DCAs are defined by certain characteristics. For example, let's look at the MS7510A2206. The S indicates it is a spring return actuator, and would be for a non-spring return fail-in-place actuator. The 75 means it has the capability to accept either a modulating or floating control signal. And the 10 means it has 10 Newton meters, or 88 inch-pounds of torque. While we are here, notice the codes for the other control signals. For instance, 31 is for communicating actuators, 41 is for two-position line volt, and 61 is for floating 24-volt. The next letter is A, and this is for standard actuators. If it were J, it would be a silk communicating actuator. It would then also have a 31 in the first part of the number, as it would be a communicating actuator. The auxiliary switches provide feedback to a controller when the actuator is fully open and fully closed. The first two indicates a voltage feedback that corresponds to the actuator position. The second two indicates an auxiliary switch, which provides a single-pole double throw or single-pole single throw contact closure if the damper is fully open or closed. These switches may be fixed at 7 and 85 degrees or may be adjustable depending on the model number. The last two digits of the part number, the X's here, do not correlate to any specific characteristic of the actuator. Silk is Honeywell's communicating bus. Silk spring return actuators are compatible with any Silk-enabled controllers, such as jade economizers and spider controllers. Silk is a two-wire polarity-insensitive bus for communication between a Silk-enabled controller and a Silk-enabled actuator, and other devices like sensors. With Silk Bus, you can daisy-chain Silk devices. This frees up input-output points on the controller. The bus sends feedback from the actuator that helps with early fault detection and diagnostics. This includes actuator cycle count. If the actuator is stalled, it even measures peak VA to warn of potential equipment issues. Honeywell DCAs help save installation time and labor. On the MN5 and 10 Newton meter non-spring return actuators, that's 44 and 88 inch-pounds, Honeywell DCA shaft adapters have a U-bolt design. Many other actuators use a self-centering shaft adapter. These make it easy to tighten an actuator to the shaft with only one hand and center automatically onto the shaft. This is critical for applications with larger torque loads. In addition, these Honeywell shaft adapters can limit actuator travel in 5-degree increments. Honeywell MS75 spring return DCAs can be controlled by a variety of control signals. This means that one model can take the place of several single-purpose actuators. They can be controlled by a two-position, floating, or modulating proportional control. It is easy to set which type of control you need. Simply use a flat blade screwdriver to rotate the mode selector dial to the desired mode to configure the actuator for forward or reverse action with a floating control signal, or setting a voltage range with a modulating control. For a 4 to 20 milliamp control signal, set to one of the modulating settings and put a 500 ohm resistor in series with the control signal wire. Silk communicating actuators need to be configured with an address to communicate properly with the controller. This is easily done the same way. Simply rotate the selector dial. All the recent Honeywell DCAs come with easy-to-access wire terminal covers. Simply remove the access cover screw and pull the cover away from the actuator. Now you can wire directly to the terminal blocks on the access cover. This makes wiring easier, especially in tight spaces, and can help eliminate the cost of an additional junction box. The access cover also has threaded openings for conduit fittings or watertight strain reliefs. It also makes field replacement quick and easy. To make the wiring simple and easy to learn, all Honeywell DCAs follow a wiring standard. Terminal pin 1 is always hot, and pin 2 is the common or neutral. Pins 3 and 4 are the control signal, such as floating, modulating, or slick bus. Pin 5 is used for feedback on modulating models. To simplify the wiring even more, you can order Honeywell DCAs with a 3-foot cable or whip. The whip is pre-wired to the actuators, so you only have to wire it to the controller. This reduces wiring time and the risk of miswiring. To properly select an actuator, there are a few parameters that need to be considered. First, determine if a fail-safe actuator is required for the application. If so, then a spring return actuator is needed. If not, then use a non-spring return fail-in-place actuator. Next, determine the minimum torque required for the application. We will cover this in more detail next. The control signal is another important factor. Two-position control, also called on-off or open-closed, is a simple on-off control signal where the actuator will drive one direction when the power is applied, then it will spring return when power is removed. Modulating control can be either floating or proportional control. Floating control is also called tri-state or 3-point. It sends the actuator a signal to drive one direction for a set amount of time, and another signal to drive the actuator in the other direction. Proportional control uses a voltage or current to set the location that the actuator will drive to. For example, if a 0 to 10 volt control signal is used, then 0 volts will signal the actuator to be fully closed. A 10 volt signal will tell the actuator to drive fully open, and a 5 volt signal will tell the actuator to drive 50% open. Silk bus is a communicating control signal. This is a digital communication signal that uses a 2-wire bus to provide control and communications between a Silk-enabled controller and a Silk-enabled actuator. Honeywell DCAs also come with optional internal end switches. This is sometimes referred to as feedback. Be sure to select a model with end switches if feedback is needed. You can determine how much actuator torque is needed with some simple math. Start by determining the area of the damper. For a rectangular damper, multiply the length and width in inches together, then divide by 144 to get the square feet of the damper. For a round damper, take the square of the radius, that's half of the diameter, and multiply it by 3.14, and then divide it by 144 to get the square feet. Once the damper area in square feet is calculated, multiply this by the rated torque multiplier. Unless specified differently by the damper manufacturer, multiply the area in feet by 7 to determine how much torque is needed. For a 24 by 36 inch damper, multiply these dimensions together, then divide by 144 to get the damper area in square feet, 6 in this example. Then multiply that by the torque multiplier, we will use 7, to get the torque required to operate the damper. It is 42 inch-pounds in this example. So you should select a 44 inch-pound or 5 Newton-meter actuator such as the MN7505 or 6105 non-spring return, or MS7505 or 8105 spring return. To help simplify the math, this chart shows the maximum damper area for each actuator series based on the 7 inch-pound per square foot torque multiplier. Simply calculate the area of the damper in square feet, then look for the actuator torque needed. For example, if a damper has a 15 square foot area, then a 175 inch-pound actuator should be selected, such as a spring return modulating MS7520 or non-spring return 24 volt floating MN6120. For round dampers, 35 inch-pounds is sufficient torque for up to 24 inch diameters, and 44 inch-pounds for up to 36 inches. So most installers use a 44 inch-pound 5 Newton-meter actuator on all round dampers, such as the MN7505 non-spring return modulating, or MS8105 spring return 2-position 24 volt actuator. For large dampers, sometimes it is necessary to use more than one actuator to provide enough torque to operate the damper, in which case extra hardware should be used, such as a tandem mounting kit. There are many ways to install a DCA on a damper. The most common and simplest is direct mounting, as shown on the left. As just mentioned, sometimes it's necessary to use 2 actuators to supply enough torque for large dampers. A tandem mounting kit is shown on the right. These 2 actuators are tandem mounted using the 5000407 mounting kit. Other mounting methods, such as using a jack shaft, are also common. Here are 2 methods to mount DCAs onto jack shafts. Jack shafts on Honeywell dampers are 1-inch diameter. Be sure to order an actuator that accepts this shaft size. The third method of installing a damper is foot-mounted. Use a foot mounting kit to install the actuator remote from the damper, and a jack shaft to connect the actuator to the dampers. This is commonly used to replace old foot-mounted actuators. All the mounting hardware needed for the various installation methods we've just talked about, along with other actuator accessories, can be found in the GFD Application Guide, number 63-9271, or the Accessories Literature Form number 63-2620. Both of these are available from customer.honeywell.com. This concludes direct coupled actuator fundamentals. For more information on Honeywell actuators and other commercial products,